I'm Erin O'Connor. Welcome to the Expert Talk Online. I'm a delivery lead at Equal Experts, and I'm here to introduce you to our guest, Daniel Terhorst-North, and he's going to be in conversation with two Equal Experts consultants and my colleagues, Marco Vermeulen and Natalia Oskina. So welcome, everyone. I'm going to quickly go over some housekeeping before we get started. So mainly this is about the question and answer function. So we're inviting questions throughout the talk. You can see at the bottom of the Zoom screen, there's a little Q&A function there. It's sort of towards the right. If you put questions in there, everybody else can see them and vote on them. So if you could use that instead of the chat function, that'd be better. Thank you. So back to why we're all here. So I'm sure that our guest needs no introduction to this crowd, and we will get to him in just a second. So first, we're just going to indulge in a little bit of getting to know one another. So Marco, Natalia, and I are colleagues at Equal Experts, but there's also a nice little connection to Daniel. He and I have overlapping careers in the past at ThoughtWorks. So for about 4 years, we worked together in ThoughtWorks UK, and that was a time when lots of wild, innovative ideas were kicking around the office, and Martin Fowler was kicking around the office. And I think we can all agree that lots of innovation that came out of this industry in that period is still highly relevant today to lots of us in our careers as practitioners. So Natalia, let's hear from you first. I think you're an experienced engineer and you've worked with solid principles and CUPID principles. Tell us about yourself.
Hello. As Erin said, that I'm a software engineer. I joined Equal Experts 3.5 years ago through the Evolve program, and grown since then. And my background is mostly a backend engineering. Object orienting, and my main principles that I was using since the beginning was solid up until I discovered CUPID. So that's in a nutshell a small introduction of me.
Okay, thank you. So Marco, you're next. You've got a passion for functional programming. We were just talking about this earlier. And you're a recently published author. Why don't you tell us a little bit more about yourself?
Yeah, sure. So I came to software in a very roundabout kind of way. I started as an electrical engineer, and after I finished studying and I started working, I discovered that that's not what I wanted to do. So I became a musician. I did that for many years, and then early 2000s, I pivoted and went back to an old hobby of mine, which was programming. And I did a Java boot camp. I've been doing software ever since, and I absolutely love it. So I'm also a backend engineer like Natalia. I love working with data and with APIs and all that sort of thing. And I really enjoy functional programming. So yeah, that's me. And of course, coming from an OO background, I was kind of rooted in the solid principles as well. So yeah, CUPID is really refreshing. So it's a really lovely new slant. So yeah, that's me.
Thanks. And Daniel, hello. I hope I hope you're going to raise some eyebrows and share some thoughts and provoke some questions, maybe even ask questions of the other panelists, and tell us about finding your own principles and bringing joy to software engineering. So let's hear a bit about you, and let's just move into the conversation and the topic about CUPID.
I'm keeping an eye on the Q&A. I want to know what Marco plays as well.
I'm a bass guitarist.
No way, you're a bass player. I'm a drummer. I'm always looking for bass players. Bass players are really hard to find. So
well, we'll speak afterwards.
Fantastic. I just found a bass player. Awesome. Anthony plays both. There we go. No, I can't read a note of music, but I can hit things and carry things, which is what drummers do. So hello, I'm Daniel. I'm a drummer. No, I am a drummer, but that's not why I'm here. I am a I guess, a 30-year veteran of technology stuff. And the reason I am opening with that rather than anything else is when we look at Solid, it is rooted in the sort of late 80s, early 90s model of how we wrote object-oriented software. OO had kind of eaten the world at this point, and it was some pretty good advice for its time. And I can legitimately say that because I was there. And one of the conversations I want to have this evening, or part of the conversation I want to have this evening, is why I think it's become redundant. It's become vestigial. It's anachronism. So it's not bad or wrong or anything like that. It was of its time. It was really, really good advice. It's now really, really good advice if you're writing software in the 90s. So I'm Daniel. I've been cutting code, I guess, for 30 years. And then around, as Aaron said, the early 2000s, I joined ThoughtWorks. I was ThoughtWorks UK's first tech hire. So there were a couple of sales folks and a managing director and things, and I was the first tech hire in the door in 2002. And my first job was to try and hire some more people. There was a rapidly growing client. And we grew that office from like 4 people to about 250 over like an 8-year period. I left there at the end of 2009. So kind of that decade, I guess, was my time there. And it really was a kind of crucible of, everybody had imposter syndrome. Everybody was an imposter. Everybody was surrounded by people smarter than them. And, behavior-driven development came out of that time. Continuous delivery came out of that time. Chris Matz and his skills liquidity. So there were lots of just really interesting innovations, not just in technology, but in process and in how teams work and team dynamics. And it was an exciting place to be. And then I left there at the end of 2009. Like I said, it was time to move on. I think ThoughtWorks and I kind of parted ways in terms of what we wanted to do. ThoughtWorks was and still is a very, very good software delivery business. They, if you want some really gnarly custom software writing, then hire them because they're brilliant at it. I was much more into understanding how organizations became more effective. So I'd kind of, if you like, I panned back from cutting code and understanding how software works and building software systems to wanting to understand how the teams that build software products work, and not just the programming, like, from front to back. So how product management worked and how we decided what we were going to build as well as how we're going to build it. My particular nerd area was build and release engineering. So I wanted to know how things got live and how they got live deterministically and consistently. And then panning back again from that, how do teams of teams work and how do organizations work? And it seemed to me there was a real opportunity to do that. And so that's what I did. I went off to try and do that, and immediately my plans were thwarted. So I've had a very, very, I'd say, opportunistic career. I think I've made one career decision in 30 years. The rest of it's just been happy accidents. Left ThoughtWorks, joined a trading firm where I went in as a, you'll appreciate this, I was working on algorithmic trading systems. So lots of back end, lots of data integration, fire hose of data, huge volumes of data, lots and lots of, quite a bit of functional programming, you'll be delighted to know. And spent a year in a very, very high performing team. And as well as writing software, I was trying to kind of understand how the team worked. How is this team as effective as it is? Because it was both writing better software than I've ever encountered in my life. Like the quality of software was off the charts, and the rate of delivery, like the speed that this team could move, was off the charts. And I'd never seen those two things coincide in quite that way. And they were also breaking all the rules, right? They were breaking all the agile rules. They weren't doing sprints, and they weren't doing estimation, and they weren't doing story points, and they weren't doing, and I measured the test coverage on the code base at one point, and it was about 7%. It turns out that it was very unevenly distributed, and it was the right 7. Yeah. So I left there after I was there for about a year and a half, and that was when I started noodling on what became, I guess, CUPID. So for the last decade or so, I've been independent. The way I describe it is now is I go into companies and cause mischief. And it's enormous fun. And some of that mischief is technical, and some of it's process, and some of it's people, and some of it's leadership, and all kinds of different things, ways of working. And there's a few things that I find timeless, right? I'm not knocking Solid because it's old. Unix is old. Unix is as old as me. It's about 50 something. And it's brilliant, and it's still brilliant. XP, practically everything in the extreme programming canon, Kent Beck and Ward Cunningham and their gang, is timeless. It's still just as valid now. Martin Fowler's refactoring has not just become canon, it's become how tools work, right? You don't need to read the book, it's all under your fingertips. So I think there's a lot of brilliant stuff that came out of that time. And I think there are some things that were really good point solutions. And Solid was a really good point solution to how do you write object-oriented code in the constraints of the 90s, in the same way, and we're asking for, Erin's asking for contention. Scrum was a really good point solution to how should we deliver software in the early 90s, and is utterly redundant now and utterly irrelevant. And the fact that it is still being taught as state of the art, how we should write software, is a travesty in our industry. But maybe that's for another day. So there we go.
I was hoping you were going to start saying some of these things are dangerous, because that's the revolutionary kind of statements people came here to hear from you.
Well, and the thing is, it's not, I'm not being deliberately, I'm not trying to be deliberately provocative. These are defensible statements. I can defend these statements. And the reason I love having a platform like this, and I'm aware that I'm doing all the talking, I'm going to shut up and do some listening and some conversing in a minute, but is that at the risk of saying nice things, Equal Expert, all my encounters of Equal Experts, literally since they were founded, like, I know the various founders well. I was watching EE when it was first, the idea was being floated around, let alone when the company was formed. And I've seen it grow and grow and grow, and the bar is high, right? And when I have conversations with Equal Experts folks, they're interesting conversations, and people will challenge, and they want to challenge the status quo, and they want to learn. So, I'm I'm here for the iconoclasm, right? I'm here because if I say things like, Scrum is completely is a complete Ponzi scheme, then people aren't going to go, oh, burn him, crucify him. They're going to say, interesting. How do you justify that? So yeah, for sure. So I'm going to be selfish. I'm really interested in how Natalia and Marco have been. So firstly, I guess how you came across CUPID, where did you first come by it, and how you've been applying it, and how it's been useful.
Natalia, you want to go first?
Yeah, I can go first. So I have been told by Steve Smith to see interesting CUPID properties. I've been looking and thinking that it's really interesting, and that is actually can be applied to a different scale in the development, not just the code. I can see it applied to level of microservices, and then going down, narrowing it. And when I was thinking about it, I can traverse my experience and see examples and projects that I have seen them implemented, and understanding why it was so easy to develop and to understand the code that I joined, or where it wasn't implemented and I was battling through to start bringing value to the project, because there were some issues or some elements that were not helping as much. I was quite, as Marco said, it was quite refreshing for me to think through. And since that, I can sort of apply a lens of perspective to the project through the properties. So Marco, what do you think? What was your experience as well?
So I came across it probably about a year ago, and started reading through it, and I started realizing that a lot of these things I'd already started subconsciously picking up. for me, the interesting thing was, I think when we started moving from big monolithic applications to microservices, a lot changed in software development as well. The code bases became a lot smaller. Teams became responsible for individual services. So you had more idiomatic code and more control over that idiomatic code in smaller groups. So it's almost like, for me, these properties just started coming forward naturally. So it's actually really cool to see. They're not principles, they're not hard laws or anything, but they're just natural properties that come out when code is good. And I think we've started seeing that happening naturally over the last few years. That's just been my experience.
That's interesting. I mean, and this is lovely to hear. So what I said when I was first talking about it, and finally got around to writing the article a year after I started talking about it, is the original challenge, and this was lovely Graham Nash. He said, okay, so you're clearly not a fan of Solid. What would you replace it with? And kind of my homework question, if you like, was what 5 principles, if I don't like Bob Martin's 5 principles, what would I replace them with? And then there was a kind of almost the meta question, which is, are there 5 principles? Are there any common features of good code? Or is it just too abstract a thing to have that conversation about? And where I got to was not necessarily principles, like rules you should follow, but properties, characteristics of the code itself. And like you say, having idiomatic code, if code is written in order to be read by people who are familiar with that world, whatever that world is, if it's a world of Kotlin or of Java or of Go or Rust or C++ or whatever it is, if people who you're not writing it for yourself, if you like, you're writing it for other people in that world. And it's that one of the sort of principles, if you like, underlying all of this is empathy, is we're writing code for other people. And so I love, Natalia, I love that you said that, and I'm hearing this as well from a number of folks, that they're using Cupid almost as a filter or a lens to look at existing projects, existing code or past code, and saying, like, I really struggled on that project, or I really struggled in that code base. And Cupid is giving me a vocabulary to understand why, or to articulate why that sucked. It sucked because there was nothing in it was composable. Everything was written to just have to tie into everything else, and everything was this spaghetti mess of dependencies. There was no composability, there was no encapsulation, there was no this idea of doing one thing well, like any particular thing I wanted, authentication, purchasing, whatever it was scattered all over the place, and it was impossible to know where everything lived, or things that were unpredictable. There's on the Twitters today, it turns out GitHub has just made a change to their web UI, where if you're in a GitHub issue and you hit Command Enter on a Mac, then it submits your comment. Only now it closes the issue. So people have been happily commenting on issues all afternoon and suddenly realize they've closed 35 issues by accident because there was a completely unpredictable UI change. There was no notification of this, and now they've got to go back and figure out which 35 things they've just closed. So thanks for that. And when you get surprises like that, and I'm sure obviously it's an accident, it's an oversight, when you get things happening like that, it damages your reputation. So making things predictable, it just leads to a happier life. So I love the idea of like using it to understand why code is easier or harder to work with. One person contacted me and said, we're using it for a code review or for our application review, where we're looking at, we've got this big gnarly system, it's really critical to our business, and we have to we have to do something with it, and we're using Cupid to come up with a plan of action. And I thought that was a really cool idea. So we're looking at, so how do we make this more composable? And again, the idea with the properties is that there's not like things are like not composable or not predictable. There's just more or less. So how do I move this code base towards a code base that contains more composability, that has more Unix philosophy of each thing does one thing and does it well, or you know, how do I make this code base more predictable, given that it was written in a language that doesn't really lend itself to testing, or an architecture that doesn't lend itself to testing? And it doesn't have the answers. What it does is it gives you a lens with which you can ask better questions.
I love that idea of using it as a code review. And I also like how you talk about it with like the humanness and driving quality and speed. Someone on the Q&A is saying that someone else called Kevlin, I'm not sure if that's good, Kevlin Henny did a similar deconstruction of solid and came up with fluid as an alternative. Wondering if you were tempted.
So now I think I've heard the fluid talk. I've seen I'm a massive Kevlin Henny fan, right? And I've seen a lot of his talks, a lot of them live, because we always seem to rock up at the same events. And when I pitched CUPID to XTC, Extreme Tuesday Club in London, which was the first place I spoke about it, he was there, and it was this evening, and they were talking about solid was the topic, and so I'd been invited to contribute as this guy who had this this post that made some craftsmen angry, and he was one of the folks there, and I said, look, I've kind of been riffing on this thing, and it really is, you know, it's a, you know, what's it, a 30-year overnight idea, right? So it's something that I've clearly been thinking about a lot throughout my career, because I really care about the code I leave behind. One of the comments I've got, actually, so Kevlin was the editor, curator of the 97 Things series, so the 97 Things Every Programmer Should Know. And I contributed something to that about writing code that's basically nice for humans to read. And the comment I say in there is, you know, be nice to the programmer who comes along in 6 months' time. And then I say the programmer who comes along in 6 months' time might be me, right? You know, I'm writing code now, and I'm writing code for future me. And so he was there, and he was, and again, with all these ideas, you know, you put loads of ideas out there and most of them just fall flat. And he was one of the folks at the meetup, and he said afterwards, I really like what you're doing with CUPID. And he gave me some just really lovely, positive, constructive feedback, about what to do with it, where to take it, how to frame it. So, and he said, you know, so it's obviously he's done his fluid talk. I couldn't, off the cuff, I couldn't, without Googling it now, or DuckDuckGoing it now, tell you what any of the 5 things are, any of his fluid are. But I suspect, again, it's a backronym. You know, he started with the word fluid because it's the opposite of solid, I guess, and then came up with 5 things. I don't know what the things are.
That's some of the same letters as you.
It's yeah, well, exactly. So I mean, and it may be that some of them are the same. But no, I didn't dip into that. I didn't go. There's no. I don't have any specific sources I would cite. Whenever I do come up with something like that, where I have looked somewhere else, I'm very, very conscientious about citing sources. I'm going to get on a little pedestal, but I'll get off it again, but particularly women, right? So I find there's a huge amount of erasure of women in tech and women's ideas in tech by men. And so whenever I have something that, or for instance, and I see this a lot, that happens to women much more than men, and maybe it's coincidence, right? Maybe it's correlation, is that someone will say something, they'll say, oh, you know, that, and they'll frame something, and then someone will immediately reply with, oh, that's similar to so-and-so's thesis from 1970 something, blah, blah, blah. And it might have a passing resemblance to something, but it's kind of trying to diminish someone's contribution by saying, oh yeah, well, some guy came up with that in the 70s. And when guys come up with ideas like that, guys tend not to reply and do that. So it's a thing I've observed. So whenever I have, you know, whenever I'm kicking around ideas, and also whenever someone takes something that I've done and riffs on it, which happened a lot with BDD. So Liz Keogh, who I'm a massive fan of, Liz Keogh, started again as a programmer, moved into coaching and team dynamics, then got into complexity and became part of the Canevin gang, has done some really, really interesting stuff with BDD. And often when people come to me and ask for BDD kind of references and resources and stuff, I'm like, mate, I'm not the story anymore. Go look over there. That's way more interesting. So, so short answer, no, I didn't lift anything from Fluid, but I'm a massive fan of everything Kevin has to
That
say
wasn't the
about most
question.
things.
It seemed relevant. What about CUPID properties taken to extremes? Is that something to worry about? Do we want to talk about that?
So this is like I'm kind of interested in seeing this because, again, they're deliberately framed in a centered way. So in other words, you know, more predictable. We're going to write software that's so predictable you'll always know what it's doing. Okay, that sounds like it should be a good thing. I think you can over-index on anything, right? So again, if you think of these as these are properties, these are not the goal, these are not the point of software. The point of software is solving a problem for someone, is some kind of useful impact. If the way you're going to create that useful impact is by hacking something together that you're going to use once and throw away, then going after these properties for something that's disposable is overinvestment. And the risk with that isn't the code you end up with. The risk is that is what you could have done with that time and opportunity cost. And we as technologists, we tend to have a massive blind spot for opportunity cost. So it's not necessarily what's the thing I'm building now. It's what are all the other things I could have done with that time, and what's the most valuable of those things, and I wasn't doing that. And this is my counter to things like TDD. TDD is a fantastic way for doing design in the small, for doing example guided design in the small. There's a lot of cases where I'm a huge advocate of TDD. I'm a big fan of TDD. There's a lot of cases where I simply don't use it. For instance, if I'm exploring something, I can sketch out half a dozen ideas in the time it would take me to TDD one of them, right? And I'm going to throw most of them away. And the one I keep, I will then go back over and apply that example guided goodness to pull it into a shape that looks, if you stand back and squint, it'll look a lot like I test drove it. And likewise, if I'm just riffing on an idea, what CUPID gives me is a towards, if you like. It says, okay, I've got this idea. You know, Erin and I have been pairing on this thing, and we think this might have legs, right? Okay, now let's take a look at it. If someone else comes and looks at this, right, is it going to pass the I'm so embarrassed about this code test? And the answer is a big fat no. So we're like, okay, we've clearly. We've clearly taken this Python and we've written Java in Python. We've got all these objects and classes and whatever all over the place, and Python, you just need to write the code you want and then stop. And so why don't we make it a bit more idiomatic? If we were to make this more idiomatic Python, well, mostly we'd delete most of what we've got. That's what we'd do. How would we make, okay, so we've got all this stuff and we're basically using language primitives all the way through. It's really not intention revealing at all what's going on here. What if we made this, what if we introduced some domain language to say what the ideas are? Yeah, that's probably a good idea. So we start thinking about these properties, and we're saying, as we move the code base towards these properties, it's going to make more sense. It's going to be more intelligible to someone who's not us. And also to us, after we've gone off and had a night's sleep and come back and gone, what the heck is this? But I think the biggest risk for anything that's about quality is about appropriateness. What's an appropriate amount of quality? Because more isn't necessarily better. It's trying to get the balance right is where we're at. One thing I did, like a thought experiment I did try with this, and again, I haven't formally done anything, haven't written anything up, is looking at, if you think of them as attractors. So as I make something more predictable, does it tend to make it more idiomatic? Are there, do some of these pull in the same direction? If I make something more domain-based and start introducing domain language around things, does it tend to make it more Unix-like? Do I tend to find that it starts doing one thing well and the other responsibilities fall out somewhere else? So do I find by introducing domain language that the code breaks apart in ways that give me that Unix-like shape? And I suspect there are some of those relationships in there, but I haven't got any kind of formal take on it yet.
There's a question from outside the Q&A that I thought was interesting, is with the CUPID properties, Does anyone on the panel find that any of those individual ones are harder to convey or take on board than others, or easier?
I can speak to that like a lot, but I won't. I'm curious about what the others.
Yeah, Marco and Natalia.
It's a great question.
It is. It's a really good one. So they all make really good sense, but I think the thing that's probably most difficult to convey, if I have to think about it, is the predictability one, right? Because that can apply at so many different levels. It could mean, and I think Daniel, you mentioned this in your article as well. It could mean deterministic, for instance, which is very true when I'm writing a function. It needs to be deterministic, needs to be pure, etc. But predictable could also apply to a whole code base, to when you come into a code base. So that ambiguity is obviously, it's quite a broad thing. It could mean so many things. So I think that's what I find quite difficult, because their properties, they're not pinpointing something specific. They're quite broad. They are sometimes a bit difficult to convey. That's just my view. Yeah.
Cool. And is that specifically with predictable, or are you finding that with some of the others as well?
So obviously, domain driven, we all know what that means, right? But once again, depending on what lens you're looking through, at what level you're applying it, it could mean completely different things. It could mean that you're talking about a bounded context in a service, or it could mean that you're actually speaking about the domain even of the language that you're coding in. So there's, once again, it's nuanced because it's at different layers. So it's very important to be very open about what level you're speaking about. I see these things applying at all different levels, and wherever they intersect with a topic, like microservices, the way they intersect, it has a whole bunch of meanings, but when I apply it to something far lower level, it means something completely different, which is great. I actually like that. I like that ambiguity, but it does make it a little bit more difficult to explain what they are.
So, Natalia, do you want to add anything, or shall I?
No, not about exactly that example. So go on.
Fantastic. Okay, so this is deliberate, Marco, and it's interesting because that's not the one I thought you were going to pick. So one of the things I say in the article is that I choose properties for properties. So what I mean by that is these 5 things, these 5 CUPID properties, I deliberately chose them and framed them in a way that is layered and nuanced and whatever. So if you say, if someone who's new to programming or relatively new to this whole world, so what do you mean by predictable? And you say, well, it does what you think it's going to do, right? And there's ways of checking that it does what you think it's going to do. You could write a little automated test, or you could write little automated examples to guide your design while you're building the thing. That's a good way to know what it's going to do. You could measure it, is a good way to know what it's going to do. So then you get exactly what you're saying, Mark, into like runtime characteristics and observability. That's a predictability thing. But then you can talk about so the idea that code is predictable as you look across the code base, that's more about the world of idiomatic and domain based, but I'll come to them. The conveying an idea and then kind of, if you like, digging into the subtleties of that idea, I see as 2 different things. So there's something about, I have a very lovely but very old whiny dog outside my study. If she wants to come in. There we go. The joys of live broadcast from home. She's now in and happy, and will now stop whining. So they're deliberately nuanced. So we can talk about predictability of runtime and behavioral characteristics is a huge, deep and nuanced world. Something else with predictability, well, with each of these properties, is that they are deliberately fractal. So I can look at predictability of a function, but then I can look at predictability of a component or of a subsystem or of an entire application. And I should be able to reason about all of those. And as you can imagine, the broader levels, if you like, kind of presuppose the lower levels. If I have unpredictable components, then when I put them together, there's no way I can build a predictable system out of that, or it's very, very challenging. So the one that I find the hardest to convey, or at least to get people on board with, is idiomatic. You're talking about idiomatic code, and largely, and this surprised me, but kind of it doesn't when you say it out loud. Largely, it's about people's egos, right? So when you're talking about writing idiomatic code, what you're really saying is, I want you to write code that's just like everybody else's code, or it's just like everybody else around here. And they're like, but I want to stamp my identity on this, you know. But I am Natalia and I am awesome. I mean, I'm sure Natalia does not do this. Natalia does not strike me as the person who does it. But, you know, I wish I am Daniel, and I have a big ego, and I have written a lot of software, and I want people to see this software and go, ah, Daniel wrote this software. He is awesome. Right. And that is the opposite of useful. And this is not just about, you know, popping ego bubbles. This is about getting work done. If I've got a code base, and as Marco's saying, you know, we're moving much more towards these small component type architectures, then what's likely to happen is smaller groups of people work on individual bits of that. You know, pairs or 2 or 3 people will work on a particular microservice. And if we all don't have a shared way of doing stuff, then every time I look at another piece of code, it's like joining a new company, right? I've got nothing, I've got no reference points. So how we solve X, right? There is no single answer to how we solve X. And that's what the idiomatic property is about. It's about, and all of this really is about reducing cognitive load, right? Making it easier to think, to reason about code. So if I'm coding in the language of the domain, and Marco, you almost certainly haven't come across this. I wrote it about 1 million years ago. There's an article on my blog somewhere, we can find it and put it in the links, called Whose Domain Is It Anyway? And it is looking at exactly this. It's saying that when we're thinking about using domain language, it's easy to miss the fact that there are a whole bunch of domains going on. So I might have I don't know, here's a Java example. I might have the patient records Hibernate repository. Okay, so the Python records, the patient records Hibernate repository. So if I look at that, I've got patient records is from the domain of probably some kind of healthcare app that I'm working on. Then a repository is a domain-driven design pattern name. So that's from the domain of domain-driven design patterns. And then Hibernate is the name of a software product, right? So that is the particular type of repository I'm using. So you've got, in one class name, I've got language from 3 different domains. And one of the thought experiments I riffed on was, what if you had an IDE that could do domain-driven fonts? So, or domain-driven. So in there, it says like patient records is in one thing, and then Hibernate is another thing, and the repository is another thing. But to understand that you're working in those different domains, and that's okay. And the important thing is to be consistent with that. So the closer I am typically to the UI or to the end user in some way, the closer I'm going to be to the problem domain, like the customer need domain, if you like. And then the closer I am to like the back end, the integration points, the guts of the thing, the more I'm going to get into computer sciencey things, right? Like repositories or maps or, you know, interfaces or adapters or those kind of things. And it's completely legitimate to have those, to mix those vocabularies, to mix those domain languages, as long as you do it in a consistent way and in a way that guides someone else. So I write that code in a way that Natalia comes along and she's like, you're using language from DDD patterns. I know those. I already feel familiar. If you've got a repository and it's doing anything more than getting things and saving things, we got a problem, right? But if I want to know where the getting and saving happens, it's probably there. Yeah. If there's a bunch of business logic in there as well, we need to talk about what you think a repository is. But right away, you have information, and it's the Hibernate repository. So if you're swapping that out for a Batis or some other thing, then you know that that's probably something you're going to need to touch. right? And so you're immediately getting information without having to crack open anything. Like the name tells you this. And the fact that you have patient records, right? Well, anything to do with patient records is the patient records domain. So this is all great. So so that you have at any time many overlapping domains, and the goal is to bring the code as close as possible to how you want to think about it. And so the domain base, the domain naming, is another element of predictability, if you like. Does it do what I think it does? Well, it depends how you named it, right? If you name it in a really obscure way, I've got no idea what I don't have a thought about what it does. So again, you see these patterns start to interact with each other.
Natalia, did you have an example?
Yeah, actually on the same topic of like structuring the code, I think it's particularly important in like for me as like consultant who is changing the projects, and then it's a time to start implementing stories, right? On the label to like understand the code faster. And when the project is structured of like separating like just all controllers, all of them separately and like separately business logic, and then you do like a vertical story when you need to open like all 100 of like folders and change one thing in everyone and find the particular like class or file you need to change. That is where the struggle to understand where is what happening. I think as well as Daniel said that those properties, they're all correlated for me. They're all sort of like merged a little bit together, because from one you can get to another. So for example, like composability and Unix properties, it feels like for me, when I think about the code, for example, like a microservice that doing one thing, and then this is a step towards the composability, because however you look at that, in this way, if microservice is very small area covering exactly only one thing that needs to done. For example, we had a notification service that only notified about the missing documents, let's say, and doesn't know about other documents or whatever is needed. They just know, should I send a notification out? So in this way, it's super easy to compose different services that needs this notification service. So it's sort of one property is getting into another, and this is sort of the hard part to implement, like to think about only one property itself, because all of them together is sort of explaining an easy way for developing and for developers, right?
Well, and I think you're absolutely right. And this is, for me, there's like a serendipity of like you're bringing the code towards one of them, and you start getting some of the others for free almost. I'm actually going to pick up your example is great, because it's the S of solid. The reason we have this problem, or one of the reasons we have all this problem with all the controllers in one place and all of the things in the other place, and in the days of J2EE, for those of you who are old enough, anyone who isn't old enough to remember enterprise Java beans, just take a moment to just think about how joyful, how wonderful your life is, because you don't have that in it. So now enterprise Java beans was like or at least J2EE was the absolute epitome of this. If I wanted to add a field to a form in J2EE, I would add a column in a database. I would add a field in a DAO, data access object, so a DTO, data transfer object. I would then add a field in a session bean and or an entity bean. I would then add a field in a servlet and so all the way right the way through. And basically my entire contract programming career in the late 90s, very lucrative, was just writing get set about 18 times to add, customer surname, right? And like I say, it's easy money, but it's not very inspiring. And this comes straight from the school, the S of solid, single responsibility principle. And this is how I describe SRP as being different from the doing one thing well. SRP talks about only having one reason to change. Now, apart from that, it's trivially easy to say to point out that any code can have many reasons, even a single line of code can have many reasons to change. the intent behind that is when you had these enormous teams working on enormous code bases in the 90s, and you would literally, like the EJB team, the people programming EJBs, in fact, Sun actually described it, Sun Microsystems, who came up with all with Enterprise Java. They talked about roles, and you had these different roles, and all of the roles communicated with each other through XML files. And so, the person programming the session bean would be different from the person making the change in the database would be different from the person programming the DTO, and so on, right? Typically across different teams even. And so when you talk about single responsibility, what you're saying is, for crying out loud, right? Don't all be hitting the same file at the same time. It's going to be carnage. Let's split that work out across multiple different places. And this is also before refactoring. So I've also said, and again, I haven't gone deep into this, but I believe that refactoring makes 4 of the 5 principles of solid redundant in a stroke. Because before refactoring, the idea, we had this this mentality of, you wrote code and then you part the code, and you wrote the next bit of code and part the next bit of code. And certainly I wrote a lot of C++ in the 90s and a lot of C, and that was what you did. To the extent that the prevalent version control systems were unbelievably poor at renaming files, because you never did that. So, for instance, CVS, which was the daddy of all the certainly open source version control systems, if you rename a file, it just forgets its history completely, right? It just immediately, all the changes you've ever made to the file, gone, right? You're starting over. And so now enter Java in 1996. And by definition, in the language definition, the class name is the file name, .java, right? And it compiles to a file called the class name .class. If you rename the class, you get a different Java file, source file, and you get a different class file. And so the combination of Java appearing, where, and if you have a package, so you're basically, packages are coupled to directory names. So if I rename a package, I'm making an arbitrarily, I'm shifting an arbitrarily deep directory hierarchy, file hierarchy, shifting it across into another file hierarchy recursively, and changing a line in each of the files, the import line changes each of the files. And I've got to make that look atomic. I've got to make it look like that just happened in one go. And that's why tools like IntelliJ were so unbelievably successful, was because this was mind-bogglingly hard if you didn't have tools doing it for you. It also broke CVS, right? Because now if I do even a trivial refactoring on a reasonably large code base, checking in files in CVS was order n for the number of files. So if I had thousands of files, that would be thousands of tiny mini commits. And also I just lost the history of all those files, right? Because they're now in a different directory. And that's where Subversion came from. Subversion was written by the same people that wrote CVS, and they went, and renaming. So now renaming was order 1. Commits were order 1 instead of order n of files. And it supported renaming as a first-class operation, so you kept the history. And then all these distributed things like what led to Git came out of those. The reason for the history lesson is it shows you how baked into the culture and the tooling never changing stuff once you'd written it was, right? So SRP, single responsibility, says put each thing that might be touched by a different person, put them in a different place, because otherwise you're going to be all over each other's stuff, and you're going to end up just getting in a mess. So it was really good advice when different teams would do different parts of the same, say, feature or the same small change. And likewise, open closed principle. So the idea is that code should be, open for extension and closed for modification. And what this is really good advice to you if you're going to be working on my code, right? What I'm saying is, Natalia, that you can mess with that stuff over there, don't touch that stuff over there, right? If you touch that stuff over there, bad things will happen. I designed it so you touch this stuff over here. And again, this mindset was never around teams of developers collaborating on the same code base. This was based on a business model that never took off, of basically selling or leasing software. So so Marco's going to go and build a healthcare app, and I've got a load of healthcare code already written, you know, for patient data and hospital management and drugs management and all this kind of stuff, and I've got all this code, and Marco can just rent this code, lease this code from me, and build his product. And as he does that, I need to give him some very, very clear guideposts about what he mustn't touch, otherwise it's all going to break. And it turns out that business model never happened, right? Because what happened instead was the web was software as a service. And so if I wanted healthcare, someone else's healthcare code, I'd get it through an API. If I wanted someone's sales code, I get it through, like Salesforce is SAP through an API, right? So they're eating SAP's lunch because I don't want to install the whole of SAP and have thousands of consultants running all over the place. What I want is being able to do sales channels, sales funnels, right? CRM. So these principles, as I say, in the 90s, we thought they were a really good idea because that was how we coped, right? You needed to know which code was safe to change because you were going to go and change code. You needed to keep all those controllers and all those models and all those views. We needed them in separate places because literally different people were going to be working on them and had different access levels. And the closer you were to the database, typically, the harder it was to get access and the longer you had to be there, and so on, right? You don't want some front end fluffy whatever coder touching the database tables. Wow, people get shot for that. So that's where we ended up. And where was I going with that? Yeah. So sorry, that's it. Yeah, so back to the plot. So your example of having all these controllers and having to open a dozen different folders is a direct consequence of single responsibility principle, projecting into how things like Rails give you a skeleton app. So Rails says, you know, models here, views here, controllers here, helpers here, a bunch of other stuff over here. I'm like, great, thanks for telling me how I architect an app. I want to lay out the code in a domain-based way, right? And you just took that option away from me by giving me this, dumping all this code on me to telling me that's what the app should look like. So, which makes it much harder now for Natalia to come along and change patient record stuff, because the patient record stuff is just sprayed all over the code base in a dozen different places. And luckily she's got an IDE that finds files really easily, otherwise she'd be there all day.
And the nice thing about the more modern languages is they actually allow you to have multiple classes and functions and so forth in one artifact, right? So you can actually
modern languages like C and C++ and Python and yeah, these modern languages that allow you to have multiple things in a file.
Anything that's not Java, right? But if you look at, say,
to be fair, even Java does, but just only one at the top. But no, you're absolutely right. And there's the crazy, I mean, clearly someone thought it was a good idea. And also you can see that Java's or enterprise Java at least, was designed by committee. And you had, sitting around the table, you had IBM, you had Oracle, you had Sun Microsystems, you had a few other sort of, I guess, second tier folks. They were the main ones. And most of the language, most of the enterprise stack design was by committee and by a consensus and by compromise. And it's just heartbreaking. The human cost, I mean, it's got to be in the billions of person hours, I reckon, lost to pointless getting and setting of data through meaningless XML files is just shocking.
Do you think that using CUPID principles is going to change your programming styles, Marco and Natalia, or might it change as people move from following solid to CUPID?
I think, well, for me personally, like I said, I've seen these things coming forth naturally. So they're giving names, or they're pointing me towards things which we've started seeing emerging over the last couple of years already. So it's just nice having these things now as pointers, almost like as health checks to see of where you're standing. It gives you something to gauge your code base against. But I think these things have already been coming forth for quite a while. It's kind of now we've just given them you know, some kind of status, which is great. What do you think, Natalia?
Yeah, I agree. It is sort of not exactly like it probably depends where you're coming from, but it feels that it is sort of, yeah, exactly, the point is to have a look at in order to like naturally think in better shaping code style rather than completely changing. Well, it depends how you've been developing before that, but it's sort of, as I said before, like a lens to look at your code through rather than completely changing, in my opinion. Sort of make it comfortable, and then when you think what can be improved, you're looking at the properties and think like, have I thought through what I'm doing in that way? Oh yeah, maybe I can improve it a bit more. Because as Daniel said, that it's not exactly the perfect label. It's always a trade-off, like, should I do it better, a little bit better, or even more better, like in a way, if I explain it, if you understand what I'm saying.
No, no, absolutely, that makes a lot of sense. And I think, and that, you just reminded me of someone else said, actually, they're using it a bit like a checklist, like a code review checklist. Let's look at this, let's look at this code through the lens of CUPID. Is it idiomatic? Would someone else have written it in that style? Someone asked what functional programming languages I'm using. So I've been, I love Kotlin. I've got a real crush on Kotlin. I think it's just such a brilliantly, what I love about it, it came out of JetBrains, and so there are a few companies that know Java better than JetBrains, right? And they are aware. So JetBrains writes IntelliJ and Rider and a bunch of other IDEs, and their gig, right? They're in their mind, I guess, the product isn't the IDE, right? The product is the ecosystem around the IDE, and they want this whole ecosystem of plugins, and they're not idiots, and they're like, Java is a real dog of a language to write plugins in, right? So Kotlin was originally envisioned as almost like a scripting type, but it'll be a really lightweight way of writing plugins for Kotlin, for IntelliJ. So that was its vision, right? And then they said, and it's interesting because it's similar to what the Go folks said. They said as they were writing the language, they found it was more fun to write in that language than in Java, so they started writing more stuff. And then it had this huge shot in the arm of being adopted by Google for Android. So Google had this massive lawyering up against Oracle for some APIs because they can't, because that's why we can't have nice things. And then part of their kind of plan B was, right, if we put everything into Kotlin, then it doesn't use any Java APIs, so we're all good. So suddenly it's become this like tier 1 supported language in a bunch of places, and again it has these lovely functional idioms. Java itself now has some really nice functional idioms, and it's kind of almost going beyond syntax sugar to genuine language changes and API changes. I've been looking at Rust, which isn't functional in the sense of functional, but it's a really, really interesting way to design a language. And also when I'm programming Python, I tend to have a much more functional, my Pythonic style is much more functional than OO. I almost never use objects and classes. And again, that for me was a whole journey from, all of the Python I wrote at the beginning was Java in Python. And luckily, I was working with Chris Reed, who's one of the kind of the originators of DevOps, if you like. And he's a brilliant guy to pair with on certainly in Python, and he just beat it into me. And eventually, I was writing Python in Python, which was joyful. But yeah, so using CUPID as a checklist is useful. I just wanted to add to chuck in a bit of a curve, but it's not really a curveball. But it was. How is it changing how you're doing things? Linda Rising, who's one of my absolute favorite human beings and one of the original patterns folks. So when design patterns, or when software patterns first came up as a thing. So there's a bunch of programmers on the West Coast of the US looking at Christopher Alexander's architecture patterns and saying, I wonder if software has a pattern language. Wouldn't that be cool? And someone asked her about, what is a pattern? How do you know something's a pattern? And she said something that just made me smile. She says many things that made me smile, but this thing made me smile. She said, if you describe something to someone and they say, hey, that sounds like a really good idea, then it's not a pattern, it's a really good idea, right? If you describe something to someone and they say, well, I thought everyone did that, then it may be a pattern, and this is kind of what I was going for with CUPID. Is I'm hoping I can go to experienced developers who've been around, who've seen really shocking code in their time and seen really lovely code in their time, and I can talk about these properties, and I can say, if we make code that's composable, this Unix does one thing and does only one thing well, is predictable, is idiomatic, uses domain-based structure, uses domain-based language, and they look at me and they're like, well, why wouldn't you? Then I suspect I might be onto something.
That's a brilliant final parting word. We just ran out of time, Daniel. So thank you, Daniel, Marco, and Natalia. And thank you for hanging out with me, Lindsay. And we have a Zoom guru who's been helping. Thank you. We have another expert talks coming up on Tuesday, July the 5th. It's called You Build It, You Run It. Sounds great, but it won't work here. Steve Smith is going to demystify some of the fears around You Build It, You Run It. Details are there on that slide and on the Equal Experts website. Thank you everyone for joining from all over, wherever you came from, and thank you for the questions, and we'll see you again next time.